Alright, this is day 47 of Sparks AP Calculus. And we're going to talk about finding antiderivatives of polynomial type functions. So go ahead and think about this question. If you had to explain to someone how to find the derivative of a polynomial type function, what would you say? Go ahead and write down your own. So pause this video and then check your answer with me. You probably would say something like this. You'd multiply the power of each term by the coefficient and then subtract 1 from the power. But what we want to talk about is how to find the antiderivative. So to find the antiderivative, you would do the opposite of each one of these operations and in the reverse order. Therefore, see if you can fill this part out. To find the antiderivative of a polynomial type function, you would pause the video and write it down. So I expect you've got the first two steps. You're going to add 1 to each power. 2, you're going to divide by the new power. This one right here, account for the constant in the derivative. That one you might not have caught. I'm going to refer to it as the don't forget the plus c. I'll show you that video and you'll understand what I'm talking about. And that's exactly what this is talking about here. If f prime of x is equal, if the integral, that is what this is called here, the integral of f prime of x dx is equal to f of x, what problems do you foresee? Yeah, it's that forgetting the constant. What if f of x equals x squared plus x plus 5, then f prime of x would be equal to 2x plus 1. And we don't have anything because the derivative of 5 is 0. Well, we take the antiderivative of this. Then we would do what we said we would do up here. We would add 1 to each power, so we would get 2x squared, and then we would divide by the new power. Do the same thing here, so we get x, and then we have no way of getting back to that 5, so we're going to put plus c after it. So let's give it a try. So find the following antiderivatives. Alright, so we're going to add 1 to each power, so 3x squared is going to become 3x cubed. Divide by the new power. So we're going to have 2x squared, then over 2, plus 3x to the first over 1. Don't forget the plus c. So we have x cubed plus x squared plus 3x plus c. And unless we have some sort of parameter to figure out what c is, we're just going to leave it as plus c, some constant that when we take the derivative of it, we don't have it anymore like up here. So the second one isn't quite as straightforward because doesn't look like a polynomial. So we're going to make it look like a polynomial, very similar to the way we would make these look like polynomials earlier when we were making them into, or we find the derivative. So we're going to take this and we're going to write this as x cubed over x plus 2x over x minus 4 over x, which is equal to x squared plus x minus 4 times x to the negative 1. Now, it looks just like this one over here. We can apply the same process. So we have x cubed divided by our new power, 3, plus x squared divided by our new power, 2, and then we have minus 4x. Actually, x to the negative 1 is the derivative of what? It's the derivative of the natural log of x. Don't forget the plus c. So we have 1/3 x cubed plus 1/2 x squared minus 4 natural log of x plus c. Voila. So this next one is a polynomial that's been factored, but to take the derivative of it, we would have to apply the product rule, and then also to work backwards, to take the antiderivative, we'd have to do something. And we only know how to do ones that look like this up here. So what we can make x plus 2 times 2x minus 3 look like the first one we did by multiplying it out. So we FOIL this out, and we get 2x squared plus x minus 6, I skipped a few steps. Now we can take the antiderivative of that. So we have 2x cubed over the power plus x squared over the power minus 6x over the power plus c, which is 2/3 x cubed plus 1/2 x squared minus 6x plus c. This fourth case doesn't look like any of the above ones, but we can make this look like a polynomial by taking this right here and rewriting it as a rational exponent. We have 2 times x to the negative 1/2 dx. So now we can take the antiderivative of that. So we add 1 to the power, so we have 2x to the 1/2 divided by the new power, which is 1/2, plus c. We simplify that a little bit more, we get 4 square root x plus c. So anytime that we can make it look like a polynomial, either by separating it out and dividing by that term underneath there, multiplying it out so it is a polynomial that's not factored, or changing the exponents to be negative or fractions instead of having radicals or denominators, all of those tips will help us get through this unit. So polynomials are definitely the easiest to take the derivative of and the easiest to find the antiderivative of, but all the same process that we've learned so far we can use to reverse the process, and we can do it with sine and cosine. So the integral of cosine of x dx, well, since cosine is the derivative of sine, and sine is the derivative of cosine, one of them is negative, this is going to be equal to sine x plus c. And you can check your answer by taking the derivative of this right here. What is the derivative of sine of x? The derivative of sine of x is cosine x, and that's what we have there. The integral of sine x dx is equal to negative cosine x dx, because the derivative of cosine is negative sine, therefore the integral of sine needs to be negative cosine. Alright, try these next 4 on your own and check your answers. So you're going to pause this right now. Alright, here you go. Check your answers. See if you got them right. Alright, so we're going to work on finding c if we have enough information. So if we have the information that's given for f prime and f double prime, we'll see if we can find c from there. So we're going to start with the integral of f double prime of x. This is going to be equal to f prime of x plus c. Now if we look above, we can see that f double prime of x is equal to 2. So then this is the integral of 2 dx, which is equal to 2x over 1 plus c. We look up here and we know something about f prime of 2, which is going to allow us to find 5. So we know that f prime of x is equal to 2x plus some constant. But we also know that f prime of 2 is equal to 5. That has to be equal to 2 times 2 plus c. So here's our function. Here's our answer, which means c has to equal 1. So f prime of x is equal to 2x plus 1. Now we're going to take the integral of f prime of x, which is equal to the integral of 2x plus 1, and that's going to be equal to f of x plus c. Alright, so then we get the integral of 2x plus 1 is equal to 2x squared over 2 plus 1x over 1 plus some c. So that is x squared plus x plus c, and this is equal to f of x. Then we look back up here and we see f of 2 is equal to 10. So f of 2 is equal to 2 squared plus 2 plus c. So that is equal to 10, which means that this c is equal to 4, and we have f of x equals x squared plus x plus 4. And we didn't have to have that much extra information to find that. Let's try it again. So I'm going to start with taking the integral of f double prime of x, which is equal to integral of x to the negative 3 halves. And this has to be equal to f prime of x. Don't forget the plus c. So if we take the integral of that, we have x to the negative 1 half, because we added 1, divided by the new power, which is negative 1 half, and then plus c, which equals 2 times x to the negative 1 half plus c. That is our f prime of x. I think I'm off by a negative right there. It's negative 1 half. But we know that f prime of 4 is equal to 2, given up here. So we have f prime of 4 is equal to negative 2 times 4 to the negative 1 half plus c, which is equal to 2. So this is negative 2 over square root of 4 plus c. This is negative 2 over 2, so that's negative 1 plus c plus 2. So c equals 3, which means f prime of x is equal to negative 2x to the negative 1 half plus 3. Let's keep going. So the antiderivative of f prime of x dx is equal to f of x plus c. So the integral of negative 2x to the negative 1 half plus 3 dx, that is equal to negative 2x to the positive 1 half over 1 half plus 3x plus c. That means f of x is equal to negative 4x to the 1 half plus 3x plus c. But we know that f of 0 is 0, so f of 0 equals negative 4 times 0 to the 1 half plus 3 times 0 plus c, which means c equals 0. And f of x equals negative 4x to the positive 1 half plus 3x. In this case, c was 0. Lovely word problems, everybody's favorite. On the next page, we're talking about an evergreen nursery selling a certain shrub after 6 years of growth and shaping. The growth rate during those 6 years is approximated by the differential equation dH dt, which is equal to 1.5t plus 5. So this is our rate of change, given any time t between 0 and 6. So if that's the rate of change, that is the derivative of the height function. So h of t equals height function. This is basically h prime of t, which is the rate of change function. And if we continue to read this, where t is the time in years, h is the height in centimeters, the seedlings are 12 centimeters tall when they are planted at time equals 0. So that means that the height function at 0 is equal to 12 centimeters. Alright, now we're ready to start. Part A, find the value of the differential equation above, that's dH dt, the rate of change, which is the derivative, when t equals 3. Using correct units of measure, explain what this value represents in the context of this problem. So, we are talking about h prime of 3, and that is 1.5 times 3 plus 5, that's 4.5 plus 5, I can't even write right, and that equals 9.5. But the question says, what is this value representing, and what are the units? So let's go back up here. This is talking about the change in h over the change in t. H is the height, t is the time. So this represents the change in height in centimeters divided by the change in time in years. 9.5. So this is 9.5 centimeters per year. So that's what the units of measure are, and it's specific to t equals 3. So we can say during the third year of growth, a shrub is growing at a rate of 9.5 centimeters per year. Alright, so now we're going to do exactly what we did on the previous page. Given information, we have h of 0 equals 12, we know h prime of t equals, and we're going to find the equation for h of t. So we're going to take the integral of h prime of t dt, and that is going to be equal to h of t, and don't forget the plus c. Super nice, they gave us, go away. Super nice, they gave us h prime of t, which is equal to 1.5 t plus 5 dt. We take the antiderivative of that, and it gives us 1.5 t squared divided by 2 plus 5t over 1 plus c. So h of t then is equal to 7.5 t squared plus 5t plus some constant. But we know that h of 0 is 12. So h of 0 equals 7.5 times 0 squared plus 5 times 0 plus c equals 12, which means c equals 12. So h of t is equal to and of course I made another mistake. This is 0.75. I'm off by a decimal right there. So it happens when I get my calculator out. Alright, let's try that again. H of t is 0.75 t squared plus 5t plus 12. This is our growth function. And it says determine how tall the shrubs are when they are sold. Well, we'll go back up. When were they sold? After 6 years. So when they're sold, we want h of 6. H of 6 equals 0.75 6 squared plus 5 times 6 plus 12. Get my calculator out, and we get h of 6 is 69 centimeters. So the shrubs will be 69 centimeters when they are sold. More particle motion problems. Particle moves along the x-axis at a velocity of v of t for t greater than 0. At t equals 1, its position is 4. That's good to know. So that means p of 1 is equal to 4. And we're given the velocity of t. I'm going to repeat myself because I just paused the video for an interruption and I forgot what I was saying. Okay, v of t is equal to p prime of t. That'll be useful information. And actually we can go further, right? That a acceleration of t is equal to v prime of t, which is equal to the position or displacement double prime. So I think it was acceleration due to gravity that got me super excited about math when I discovered that if you knew the acceleration You could work yourself backwards or get back to the position as long as you need one place along there. Anyway, I thought it was super cool. So we know the velocity is equal to, I'm going to go ahead and write this as t to the negative 1/2 because that makes it easier to do stuff, which means that the prime of t is equal to negative 1/2 t to the negative 3/2. And since acceleration of t is equal to the prime of t, a of t is equal to negative 1/2 t to the negative 3/2. And we want to know what the acceleration is at t equals 9. So a of 9 equals negative 1/2 9 to the negative 3/2. So 9 to the 1/2 is 3. 3 to the negative 3 is 1 over 27, which leaves this to be negative 1 over 54. And that is in, well, it doesn't give us anything. It doesn't give us any units. Alright, negative 1/54. Alright, so the next is, what is the position of the particle when t is equal to 9? Well, the position is going to be equal to antiderivative of the velocity. Right, so the derivative of the position, which is the velocity, is equal to t to the negative 1/2 dt. So the antiderivative of that is going to be t to the 1/2 divided by 1/2, which is equal to 2t to the 1/2. Don't forget your plus c. This is our position. But we do know something about the position. We know p of 1 is equal to 4. So we want p of 1 is equal to 2 times 1 to the 1/2 plus c. That's equal to 4. So we get 2 plus c equals 4, which means c equals 2. And the p of t is equal to 2t to the 1/2 plus 2. And we plug in 9 into that, and we get p. My 9's look like a is equal to 2 times 9 to the 1/2 plus 2, which equals 2 times 3 is 6 plus 2 is 8. Voila, and that is day 47. And I will see you next time.